All right. Thanks everyone for joining today. Today's session is Serverless IoT with ArcGIS and AWS IoT Core. My name is Mqtt Test. I'm a Solutions Architect at AWS, and we'll go ahead and get started. For the agenda today, we'll talk a little bit about serverless, what it is, why it's all the rage, Amazon S3, our simple storage service, IoT Core, AWS Lambda, and ArcGIS Online. We are also going to build the solution today, so we're going to fully build this out. We're going to set up IoT Core. IoT Core is going to stream. We'll have traffic coming in through Mqtt that streams into IoT Core. IoT Core is going to forward that traffic to an S3 bucket. We're going to have a S3 event trigger that's looking for objects to be written to the bucket that will then trigger a Lambda function to automatically grab that file and upload it to ArcGIS Online and create a feature layer. So why is serverless all the rage? So serverless takes pay by usage to a whole nother level. Normally create a something like an EC2 instance, and whether or not that EC2 instance is getting traffic, you're paying for those resources. So with services like AWS Lambda and AWS Athena, which is a managed query service, those services you don't pay for them unless you're invoking them. So with AWS Lambda, you can take a snippet of Python code and package that up into a Lambda function and then invoke that Lambda function. And you only get charged for when that function is being invoked and is running. Where if you had to run that Python function, on an EC2 instance, you're paying for the EC2 instance the entire time that the instance is powered on and running. You also have no servers to manage with serverless applications. So again, when we spin up, an EC2 instance, we have to install security agents on that instance. We have to patch the instance. All the management that goes into, having an operating system that you have to log into and manage. Also, another benefit is scaling. With services like EC2, you kind of have to monitor at the application level when to add more EC2 instances. Do you scale when CPU gets busy or when memory gets busy or network? With services like AWS Lambda, there's no scaling needed. You just invoke, whether you invoke that API call to trigger Lambda, once a second or 100 times a second, there's no scaling to configure. Also, services like DynamoDB, our managed NoSQL service, that with services like that, you either have a knob to turn on how fast you want to go, or there is also auto scaling capabilities built into that as well. Lastly, the ease of getting started. So again, if we look at deploying a snippet of Python code on an EC2 instance, you're going to go and provision the instance and set up all the dependencies. With AWS Lambda, you log into the AWS console and you basically have a text box sitting there. You can copy and paste the snippet of code you want to run and hit deploy, and you're done. That's all you have to do. So it's significantly easier to get up and started, to tear down and rebuild and clone. Very, very, very simple. But so serverless is more than just compute, right? So we have AWS Lambda. We have a new serverless container offering called AWS Fargate. Again, if you've done any work with containers before, the infrastructure required to get containers up and going, deploying Kubernetes systems. Sometimes if you just have a container that you want to run, you can upload that to AWS Fargate. You say, here's my container. I need 1,000 of these. And you click deploy, you're good to go. Data stores like Amazon S3, Aurora Serverless, DynamoDB I mentioned before. Aurora Serverless is another really cool one. So we have an Aurora Serverless Postgres database instance. This is like a traditional Postgres database. It looks and behaves just like a Postgres database. It uses the Postgres client. But the instance has been optimized on the AWS side to spin up and down very, very quickly. So you can go and set up a Postgres Aurora Serverless database, and then start running your queries against it, and then all your users go home for the night, Aurora Serverless will actually detect. You can configure, when for it to spin down, but it'll detect maybe after an hour it hasn't had any queries come in, and it'll actually power down automatically. Well, then when your users come in the morning and they log into their instance of their workstations, they turn on ArcGIS Pro and try to query this database that's been shut down, we still have the listener up and running on our side. So your connection to that database will complete, and then on the back end, we'll go and spin the database up automatically. So the first request that comes in, there is a little bit of a delay. I think it's like 15 seconds or so for that first request, because we got to go in and spin the database up really quick. So it'll kind of look like a long-running query to the application. But then subsequent queries, once it's up, it's just like any other database, right? So, millisecond latency for your queries. Other services like EventBridge, API Gateway, or Managed REST Service. SQS is a simple queue service. We have simple notification services, a way to send emails and text messages, and then step functions, which can act as a state machine. And then I want to spend a little bit of time on Amazon S3. So we're going to be using S3 today just to kind of temporarily store some data. But S3 plays such an important part in geospatial workloads for storing rasters and creating mosaics. So S3 is our virtually unlimited object storage offering. Massive scale, unmatched durability, availability, exabytes of storage stored on Amazon S3. We get trillions of objects, millions of requests per second. We see peaks of 60 terabytes per second per day. So that massive scalability. Also with S3, since its launch in 2006, we've reduced the price of storage 80% to 2020. So continuing to decrease the price, but also continuing to innovate in the service itself. So we originally launched S3 standard storage. Then we launched Glacier, which is a deep archive storage. We have infrequent access, and I'm going to cover all these on the next slide, actually, because I want to talk about kind of what you would use these different storage classes for. So S3 standard is where you want to have, it's kind of your general purpose storage. Frequently accessed data, you're going to get millisecond access latency. So roughly 2 cents per gig. This is where you would keep your raster tiles and big data sets, large text files you want to analyze. Then we have another storage class called S3 standard infrequent access. This storage class is for objects that are not accessed as frequently. You get the same millisecond access response time as standard S3 storage. We're going to replicate that data to 3 of our availability zones, just like standard S3 storage. But you get a cheaper storage rate here. So this one's only a little bit over a penny per gigabyte for storage. The difference, though, is that there's a retrieval fee for the data. So there is a balancing act kind of if you put something in S3 versus standard S3, if you access that object more than a handful of times in standard S3, it actually becomes cheaper to leave that in S3 standard. So you want to balance out, you're getting the penny per gig for the data, but if you're accessing that data frequently, it's going to be more expensive. Next, we have S3 one zone IA. So this drops down to right at 1 penny per gig. The difference here is we don't replicate the data between 3 of our availability zones or multiple data centers, facilities. So you lose a little bit of redundancy. So if you have data that can be reproduced, it's a good candidate to go into one zone IA. If you've got backup of the data, or the data is programmatically created from other data sets, those are good candidates for one zone and frequent access. We have S3 Glacier. So this is where the storage prices start to get very cheap. we get down to about half a penny per gigabyte for data. But with Glacier, the retrieval time for that data can be up to an hour. There's a way to expedite the retrieval request and get the data back in like 4 or 5 minutes. But again, if the data can be accessed on that kind of time frame, then Glacier is definitely a good option. We have a service called S3 Intelligent Tiering. So if you don't really know what data you have and you're not sure, you don't want to handle managing it, moving the data back and forth between standard and infrequent access or Glacier, the intelligent tiering option will actually use machine learning algorithms to detect the access patterns for each individual object and handle moving the objects in and out of these storage classes for you. So it's kind of an easy way. If everything's just sitting in S3 standard today, it might make sense to enable intelligent tiering and let the managed service move the data between the storage classes and save a little bit of money. Lastly, we have deep archive. So the difference here, so we get down to about 1/10 of a penny per gigabyte. You get the data is replicated across 3 availability zones, but you only have the option to retrieve that data in hours. So you lose the ability to do the 4 or 5 minute expedited retrieval. So the difference between the patterns, right? So if you have frequently accessed patterns, you're going to want to put that data in either S3 standard or S3 intelligent tiering. With infrequent access, you could use, you could still use standard. You could use infrequent access or one zone infrequent access. You could use the intelligent tiering as well. And then for changing access patterns where the data is unpredictable, then you're definitely going to want to use something like S3 intelligent tiering to manage that. So we also have a policy that you can write on these buckets called lifecycle policies. It's an easy way to kind of write a simple script or policy that says, maybe move any data that's in a bucket that's older than a year to either infrequent access or Glacier. You can have it, delete certain items that are older than 5 years, like maybe you don't want to store any data older than 5 or 10 years. Gives you the ability to write fine-grained policies to move the data automatically, programmatically. Using encryption. So checkbox encryption, right? If you want to encrypt a bucket, you just check that you either need, the AES 256 built in, or you want to provide your own encryption key. We have an S3 inventory feature that makes it really easy to search the contents of a bucket. Again, if you have a lot of data in the bucket and you don't know what's in there, you can enable inventory, and we'll go ahead and essentially create a list of everything that's easy to search. We have tools to do kind of the analysis for you, right? So if you don't know what data you have, you could run some of these analytics reports to see how frequently the data is being accessed. So an example report of this, right? So objects accessed less than 30 days or 30 to 45 days, how much of the data in the bucket. So an example, maybe you have S3 objects age 60 to 90 days, you have 682 terabytes. It'll help you identify which objects to move to other storage classes. So we have a nice chart here that kind of shows some of the different storage options on AWS. So when to use one over the other. So you have Elastic File Service, which gives you the ability to do NFS mounts. It's kind of on the higher end on the cost size. The capacity range is going to be probably under a terabyte. You're going to get low latency, high throughput. S3 standard's a great option, though. Like, it's kind of the best of all the worlds. I'm not going to go through every column on here, but the main one I want to call attention to is really S3 standard being a great general purpose option, but also the last one here, ephemeral. So when you spin up some of these EC2 instances, they actually come with like scratch space. These are drives attached to those instances. It's ephemeral storage. They're very quick. I mean, they're included with the instance. And the caveat is that when that instance powers off, all that data gets wiped out. So the workflow would look like the instance would spin up, maybe it goes out to S3 to download a bunch of data to the ephemeral storage. And then that way all the data is local and you can access it, with low latency, high throughput. We also have a couple new storage options coming out, like we have FSX file gateway that has a lot of opportunity, as well as the AWS storage gateway, which I would recommend checking out. Storage gateway can do NFS and SMB mounts. It can run on-prem and replicate data back to S3, or it can run on an EC2 instance. Lots of potential there. All right, so I'm going to jump into the first step of the demo. We're going to go ahead and configure S3. This is going to be pretty short. We're really just going to create an S3 bucket. I'm logged into my S3 console. Click on the S3 service. Click create a bucket. We give it a bucket name. And create. All right, so now we have a bucket where we can store objects. And that's basically it for step one. Again, that was a quick one. But now we're going to get into the fun part here, which is AWS IoT Core. So again, AWS IoT Core, massive scale. We manage billions of devices. The service sees trillions of messages. We use the Mqtt protocol. We also support HTTPS, WebSockets. We have a new service we launched too that can assist with LoRaWAN management. It'll stand up a LoRaWAN service, a server that again is integrated and can easily bring traffic into IoT Core to work with. So the main protocol for IoT Core is going to be Mqtt based on the 3.1.1 standard. Supports QoS 0 and 1. We've got the developer guide in the link below that kind of goes in depth to the Mqtt protocol standard that we use. For some of the devices that use HTTPS as well, we can support that but it's also worth checking out another streaming and analytics service we have called Kinesis and Kinesis Analytics. It's great for handling HTTP traffic. The identity service inside of AWS IoT Core is going to be based on X509 certificates. We also have the ability to craft fine-grained IoT policies to control, which devices have access to what. The rules engine is one of the capabilities we're going to be using today. It gives us the ability to transform, enrich, filter, and route the traffic that flows into IoT Core. What that looks like is we have IoT Core configured. We have our device uploading data. You're going to write a SQL query to essentially filter the data. So today we're going to write a simple SQL query. But in this example, so we'll say select all the attributes from this message that came into topic XYZ, but only select where one of the attributes temperature is greater than 35. We also support math functions inside these SQL statements. So you could say, this could be an average where the number's an average, or maybe data that is between two dates, or string parsing. And then you can also bring in Lambda as well. Once we have a match for one of the rules is going to trigger, and then it's going to send the traffic off to one of the other services you've configured. You can send it to Lambda, Kinesis, S3, IoT Analytics, Dynamo, Elasticsearch. There's actually like 10 other services, or 12 other services, I think, that you can forward it to. In the example today, we could go to AWS Lambda and do some neat stuff. I'll show an example of that later, but we're going to go straight to S3. IoT Core also has a feature called device shadows. It's really neat. So again, we have a device that's uploading data. Our application is querying that device. But given that IoT devices, are sometimes very remote and have unreliable connectivity, let's say, a alien ship comes and runs off with our device, our application isn't going to break when it tries to query that device. So IoT Core will keep the last state of that device, and when your application queries it, it'll reply with the last known state of the device. Then when the device comes back, it'll actually synchronize to its most recent state, so that the application, when it goes in to query it again, will just get whatever the latest state is. So IoT Core highlights: fast, seamless, secure communication, easy device management and monitoring. We have another inventory feature capability for IoT Core, again, that makes it very easy to tag, millions of devices, easily search and index those devices if you want to search based on a tag. The device management feature is very robust. Reduced dev cycles on embedded IoT devices, data collection and analytics capabilities. And we'll go into the next step of the demo. So we're going to go ahead and set up IoT Core. So we'll go back to the console. Go into IoT Core. Go down to Act, Rules. Create our rule. And here's that SQL statement that I talked about earlier. Go ahead and drop in our SQL statement. And so my example today is going to be kind of like a smart meter example. So we'll say we have some smart meters out there. We're going to say the attributes we want. Select device ID, production kilowatts, consumption kilowatts, latitude, longitude, address from the IoT/ArcGIS topic. We'll create our action. And here's all the actions I mentioned before. So we can send it to Dynamo, SNS, SQS, Kinesis, CloudWatch metrics, and Elasticsearch cluster. We're going to send it to S3 here. There's our bucket. Configure action. We'll select the bucket we just created. And so this is another cool feature too. So the file that's going to create in our S3 bucket, we can actually pass in a function into the naming piece itself here. So when the packets come in from IoT Core, we're going to grab the device ID attribute from the message, and that's going to be the name of the file that gets created on S3. I select a role that has the ability to write to S3. Add action and create rule. And there we go. Now we have a rule. All right, so the next service we're going to use is Lambda. So with Lambda, right, you have no servers to manage, just focus on the code, easy scaling, sub-second metering, lots of support for libraries, Node.js, Java, C#, Go. Also have support for bring your own code. You can take even containers and upload containers into Lambda. Support synchronous or asynchronous invocations. We have flexible resource models, so you can configure 128 megabytes of memory for the instance, upwards to if you have if you need 10 gigs of RAM for the function, you can provision up to 10 gigs. What that does too is it configures CPU and network proportionately. So if you give the instance more memory, it'll have access to additional CPU and network cycles. These instances are stateless, so when they run, there's no data saved. So if you need some type of stateless capability, you'll want to use something like state. You'll want to take that state and store it in persistent storage like S3, or you could use step functions, the AWS step function service. Here's a walkthrough of the code that we're going to deploy on Lambda. Basically, we're importing a couple libraries. The main one, right, line 7 is going to be the ArcGIS library. Lines 8 and 9, we're going to declare clients for S3, one to read the data that we upload to S3, and then another client that's going to go into our secret manager, our parameter store, and grab the secrets that we use, our username and password. We're going to grab the object from the S3 bucket, grab our attributes from it, the device ID, production kilowatts, latitude, longitude. And then, so what I'm doing here is I basically write that to a CSV file in the scratch space of Lambda. That was just some code that I had on hand to do this with. Like, I think ideally you'd want to send that over, as JSON or GeoJSON or something. I don't have the code for that, but I would imagine that would work, and then also be able to do it in memory versus using the scratch space of the instance. But there's no, it's not that it's necessarily a wrong way to do it. Like, this way works perfectly fine. It's perfectly acceptable. Just there's probably more efficient ways to do that step. Then lastly, line 32 is where we create our GIS object. And then 33, we call gis.content.add with our CSV file. We're going to have the function sleep for a couple seconds, just because there's a little bit of a delay from when you add the file and that it's available, eventual consistency. And then we're going to take the item we created and we're going to publish it into a layer. Some Lambda best practices. Try to minimize package size. Don't import libraries that aren't needed or you're not using. Try to separate the Lambda handler from core logic. When that function runs, there are some parameters that are declared kind of outside of the main function loop. And by putting kind of global variables that don't need to be declared often outside of the function loop, it's a bit more efficient. Leverage max memory used. So when that function completes running, it'll actually return how much memory was used. You can use that to right size your functions. Keep an eye open for concurrency. You can start to hit initial throttles when you start to get around 1,000 Lambda invocations per second concurrently. Delete large unused functions. Typically, if you have around a 75 gig limit for how many of these Lambda functions you've created. So if you have a bunch of large functions, you can run into that limit. And then lastly, leverage the ecosystem. We have a lot of services integrated with AWS Lambda, services like Code, our services like CloudTrail to grab the monitoring logs from Lambda. AWS X-Ray is a really neat one because it'll actually do like application performance monitoring. It'll measure how long your functions took to run. And then it'll also measure some of the other components in the solution, right? So if you're making a call to DynamoDB, it's aware of that connection, and it'll go out and measure the time that it took to query DynamoDB and the round trip response time. And let's go ahead and set up our Lambda function. Go to create function. So you can select a library. You have a bunch of different libraries available. Going to select a IAM role that has access to grab the file from S3 and create. And so this is what I was mentioning before. So when you create this Lambda function, you have the editor right here in the console. So I could start typing away, the Python function I need, copy and paste it in here and hit deploy and have it be running. Now the function that I'm going to upload today is a little bit on the large side. It's 9 megabytes. So when I upload it, this text box will actually disappear and it'll tell me that my function is too large to use this. But we have a feature called Lambda Layers. And so in a lot of the ArcGIS Python development I've actually created a layer for the ArcGIS library. And then I can attach that layer to the function. And that way I retain this IDE that's built into the console. It makes it much easier to make changes and troubleshoot. So go ahead and upload our function. All right, and our function is uploaded. And see, now we're ready to go. So I could start invoking this, and that Python function could be running live in production. All right, so for the next step, we're going to go back to the console here. Oh, sorry, 1 second. I got to update one of the parameters. So by default, when you create this Lambda function, it has a default timeout value of 3 seconds. It takes a little bit longer than that to upload our file. So we're going to go ahead and edit the timeout here. And just change it to a minute. Okay. So now we have to create the S3 event trigger. And so what this is going to do is it's going to monitor the S3 bucket for changes. And when changes are detected, it's going to invoke our Lambda function. On properties, go into event notifications. We can narrow down the event to certain prefixes or suffixes. We're just going to monitor anytime an object is put into the bucket and invoke this Lambda function. Here we could choose if we want to do a notification service or a queue service. We're going to do Lambda function. Select our function we created and save changes. All right, and so we should be ready to test. So if we go into IoT Core, we have an Mqtt simulator built into the console that we can test with. So Mqtt Test Client. And so I'm also logged into my ArcGIS portal here. So you can see there's no, we're going to create an object called smart meters. Doesn't exist yet. We're going to subscribe to our IoT ArcGIS topic. Go to publish to topic. And so here's my example message. It's just our device ID is just going to be house 2, some fake production consumption info, 123 fake street for our address, and then a latitude and longitude. So go ahead and publish that. And since we subscribe down here, we can see our message on the topic. Just go back to Lambda, double check the logs and make sure everything looks good. We have this button here, View Logs in CloudWatch. I can see some logs, so it looks like our function was launched. And this looks good. So I can see the data. The Lambda function was able to read the file on S3, prints out the data. And then this is actually a response from ArcGIS Online saying it was able to create this item, smart meters. So if we go into our collection, refresh. There we can see now we have smart meters, the CSV that was uploaded, and our feature layer. Click on that. Here's the data we uploaded. So last updated was today at 3:19. Now if we go to visualize. Well, you can see it's just a single location here. And so we could schedule this to, if you had all these smart meters uploading data, to kind of go in, every day or, once a month or something, and go and grab all that data and upload it or update it. There's a lot of flexibility with what you could do there since it's being done programmatically. All right, so back to the presentation. A couple more slides and then we'll go into Q&A. So the example we did today was basically straight from traffic coming in to IoT Core directly to this S3 bucket. We would consider that kind of our raw data coming in. Then we have the Lambda function pick that up, write it to ArcGIS Online. We could start to build a data lake with that S3 tier. So we could have some data coming in, and instead of going straight to S3, maybe that goes to AWS Lambda. And then inside that Lambda function, maybe we join it with some other data. Maybe we query from the Lambda function an SAP database or a different geo database to enrich the data. And we could store that in a separate bucket called enriched. Maybe we just need to normalize some of the data. We could do some simple transformations and then store that into another folder called transformed and start to populate our data lake. So we have a free tier with S3. We have 12 months free on Amazon S3. You can have 5 gigabytes of storage, and then not be charged anything for that for 12 months. For Internet of Things, we have a free tier of 250K messages for 12 months, and then Lambda we have an always free tier. Where you can do 1 million invocations of Lambda free per month. Also encourage you to check out some of the other resources that are available on AWS. So inside of S3, we've got a lot of data sets in our open data registry. We have aws.amazon.com/earth. There's climate models, aerial imagery, elevation models. Recently, there was an article. They're going to store all the Sentinel-2 imagery on AWS S3's open data. I think it's like a petabyte of data or something. Massive data registries that when you're running your workloads, you don't have to clone that data into your environment. You can just pull it directly from where it's being stored, in these open data registries. Compliance, right? So all the services we use today are FedRAMP moderate and FedRAMP high approved. So Lambda, simple storage service, S3, AWS IoT Core, also Amazon or Postgres. All right, and that's all I had for today. I posted the code that I showed earlier to GitHub. So if you want to go ahead and clone the repo, it's there and available. We'll hop over to Slido to check some of the questions, see if there's some questions I can answer. Not that one. So first question, will these slides be available later? Yeah, we can share these slides. I'm not sure. Not sure how to share them, but I'll try and figure out and try and get these shared out. Next question, can we use the ArcPy Python library with Lambda? I've had issues with some of the licensing requirements. So I don't know that ArcPy can run in Lambda yet. I think there are still some licensing requirements for ArcPy. The ArcGIS Python SDK, though, can run in Lambda. The other thing with ArcPy is it's a huge library. So when we get to the point to where that could be run, as a function in the cloud, that we might have to look at something like using our glue ETL service to host something like that, or go in and pull out the libraries that you need and use those. It's common to see some of the larger libraries, like I'm trying to think of the science libraries like NumPy and Panda. Some of those will fit in Lambda on their own. I've seen those used in Lambda. And then some of the larger ones, you'll use our ETL service, AWS Glue. So I shared the code for Lambda. Let's see. So here's one. Where does the IoT come into play? The triggering of the Lambda function itself could be done through an IoT device. And you could absolutely load the AWS Python SDK onto a Lambda function and directly invoke those calls and go straight to ArcGIS Online. I think one of the benefits of going through AWS IoT is it gives you the ability to aggregate the data. So if you want to say, I want to send a week's worth of data, you can queue the data in IoT. We have a service called IoT Datastore. It's a time series based data store to easily store increments of data and then upload that in batches. The other additional capabilities, right? So we have on AWS, you could have that data go through some of our machine learning capabilities to maybe transform some of the data and then take that and upload it to ArcGIS Online. And then also, as I mentioned before, some of the IoT Core capabilities around device management. So some of these devices, they might not have the processing power to run something like a Python library on it locally. And maybe they, have just enough power to run the Mqtt library. And then if you wanted to talk Mqtt, you'd want to go through IoT device, IoT Core. And then you get that device management capability of IoT Core. Can Lambda be triggered on the write to S3? I think we covered that. That's basically what we're doing. So there's fine-grained policies in S3 to, you could say anytime an object is deleted, trigger the Lambda. Anytime an object is, written, or even, if it's modified. There was like 15 different checkboxes in that event notification to filter out so that you're only triggering events on the data that you want. So what's inside the zip file that I uploaded to Lambda? Basically, inside the zip file is what's on that GitHub repo. And I'm glad you asked this, because to clarify, basically with the GitHub repo that I published, if you do a git clone on that, that's exactly what you're going to zip up and put into Lambda function. So the contents of that are really what's in that GitHub repo. It's the ArcGIS Python SDK library and a Python file that is the code that we went through on one of the previous slides. So there's really not a lot in there. All the folders and files that are inside of this GitHub repo are mostly just library dependencies. Really what it comes down to is the ArcGIS Java, Python library, and then the Lambda function file. Are there any published tutorials that shows what we went through today? Not yet. I published a blog recently that shows how to use ArcGIS JavaScript as a hosted file on S3 that talks a little bit about some of this. I'm going to try and turn the presentation that we did today into another blog post. So stay tuned for that one when we get it published. Hopefully, try and get that one out pretty quick, maybe in a month or two. Next question. Any plans to support Windows 10 IoT Core? So I've done a little bit of development with Windows 10 IoT Core on a Raspberry Pi. I don't see that being a limitation. Like I could write to AWS IoT Core from that device. I didn't have any issues. I don't think there's a limitation there. I'm not sure about Event Hub. Another question. So there's a question here about Lambda cold starts. What the Lambda cold start is when these Lambda functions, if they don't get invoked in a while on the back end, they'll kind of spin down. Kind of like I talked about with that Aurora Postgres cluster. If you don't invoke it, maybe, and I'm not sure what the timeout is, but maybe an hour or something. On the back end, those services kind of deprovision. Then when a new request comes in, it's called a cold start. So with some of the larger frameworks, we saw some startup times that were higher, and I think like high milliseconds. I don't think it ever got into the second range, but very high millisecond latency for some of these like a very large Java Lambda function. I haven't seen that really been much of an issue with the other languages, but also there was some recent features published, I believe, that address this. So I don't think the cold start issue is a problem anymore. So what is a good workflow to integrate ArcGIS and AWS for real-time analytics? That's something I'm experimenting with a bit. I think we'd probably have to bring in, I think you could do probably close to real-time with something like this. I mean, end-to-end from that data coming in to being available on the map was, probably a couple seconds, or well, not a couple seconds, but under a minute. So, the definition of real time is kind of fuzzy, but if you're able to have data come in and have it available within a minute, that's pretty close. But sure, there are, higher real-time requirements for that. For that, you'd want to bring in something like a geo event server or ArcGIS Velocity. So the next question, can geo event server be added into IoT Core, or is geo event best placed in an EC2 stack with a connection to IoT Core? Yeah, so what I think that architecture would look like is you'd have IoT Core kind of as your device management layer. So from an architecture standpoint, you'd have your IoT Core kind of as your device management layer. So that would be, talking to millions of devices, and basically doing some filtering, maybe some transformation, aggregation, and then you would filter the data down into what is needed to send over to geo event server. So you don't have millions of devices trying to overload geo event server, and then you could do fine grain all your spatial analytics and that inside of geo event server, and then create that into either a stream layer or pass that on to ArcGIS Online from there. or bring it back into AWS for, additional, maybe again, you want to use like our machine learning service SageMaker to run some analysis as well. Next question, are there any plans to support alternatives to MQTT like Rabbitmq or Grpc? So I know we have some support here from an integration standpoint, like we have a managed MQ service. For Grpc, I don't know that we have a managed service, but I think you can do some stuff with loading those libraries and Lambda functions. Also potentially some capability with API gateway. So I think that would be the solution there.